right, sorry about that, everyone. Had some weird audio issues. I appreciate you guys coming back. Good morning. My name is Alex Shanicki. I'm director at TriStar. I'm here with Cody Wiltrout, application engineer for PTC's Center of Virtual Excellence. Today he's got an overview for you on the powerful new CFD extension for PTC Creo. After the presentation, we'll have a short Q&A, and a replay will be available shortly after, especially for those that were hanging in for us, with us. Cody, are you on the line?
Yep, I'm here. Can you hear me all right?
Yep. So
right.
Whenever you're ready, let's get this going.
All right. Well, then let's see. So can you confirm you can see my PowerPoint?
Yes, sir.
All right, perfect. All right, well then, nice to meet you all. My name is Cody Wiltrout. As Alex said, I'm with PTC's Virtual Center of Excellence. It's nice to be here today, and I will be going over Creo Flow Analysis, a new extension to Creo 5. So to start off here, just some challenges that really led to PTC deciding to create this extension for Creo. Engineers often don't have the classical training to perform, fluid flow analysis, at least not in depth. And if you do want to do that, it often requires that you get a third-party tool that can not only be expensive, but it can, depending, be hard to work with. Trying to take your models from your CAD tool, import them into the CFD tool, making sure you have someone who knows how to use that CFD tool. And it's fairly time consuming. And because of all of these issues, it's often, performed late stage in your design process, not something that you're doing out of the gate to really get a better idea of what you're making. And to go along with that, because of those issues, you end up having a reliance on physical prototypes. Rather than doing some simulations on it, you just build a prototype and try to test it that way instead. But prototypes can be expensive, and if you do find any issues, now you've got to make a new prototype, and you're probably making those prototypes fairly late stage in the design process, so that could end up pushing back your budget. It's going to make it, it's going to push back your project. Going to increase the cost, possibly push you over budget, put you delayed, not things that you want whenever you're working on a project. So the solution to that can be found with the new flow analysis extension, which allows you to make that flow analysis part of your early design process so that you can stop relying on late stage prototypes and start seeing improvements in your design early. So some capabilities that back this up as a solution and as an extension. It's designed to be easy to use for all engineers, not specialists. So you don't have to be someone who knows, a ton about fluid flow analysis to be able to use this tool. It's designed so that, someone who is a designer can go into this extension and use this to help improve, whatever it is that you're making. Along with that, it has a seamless workflow between CAD and CFD. So I talked a little bit earlier about, with other tools, you have to export your models. Hope you don't have any import problems when you go into the flow software. With this, it's just seamless flow right between the two of them, so that you can make CFD part of your design and do that quickly and easily. You also have easy flow model creation, so it can help to create, for example, here the mesh. So you don't have to, know a lot to be able to do that. It can help you through that process. It can generate the mesh for you automatically. It knows in areas where, you have curves or something to make a more refined mesh so that it can be accurate. But in areas that are more, general flat surfaces that are easier, you can, expand out that mesh, make it a little bit less refined, help the process run faster. And along that train of thought, it does have a pretty fast simulation turnaround so that you can get your results back pretty quickly and you're not waiting hours at a time to get those. And the results are highly accurate with different ways to view those. So in this image here, we're seeing a section view going through. You can set up plots, you can do ISO surfaces. So lots of different ways to, really be able to take in that information and utilize it, not just have it, but actually get it in a way that you can understand it and be able to use that going forward. So that covers kind of at a high level the introductory to it. I'll go ahead and jump into the demonstration now so you can get a feel for what it looks like. So we're going to be working with this inverter for today's demonstration. And for the for this here, here jumping back into the demonstration, we are going to be working again with this inverter here. And to do that, we just come in to our applications and you choose the fluid flow. And once we do that, we're going to start by just picking our fluid domain creation here. So with the fluid domain creation, we start by just selecting faces that we know the fluid will be flowing through. So we select the front and back face in this case, and it's going to detect all of the holes for us automatically. Now, when you do this, you should be careful. It can detect things that might not be holes. So in our case here, we have a switch and a plug outlet. And with that, obviously, you don't want to have flow going through those areas. They're solid, so we can select those and remove them. Once we do that, we can simply choose to add that to our simulation, and it's going to now have an idea of where that fluid's flowing through. So if we turn off our CAD body and we just look at our fluid flow body, we can see kind of how that looks. Now, obviously, everything inside of there is not something that fluid can flow through. So the next thing we're going to want to do is select the simulation domains. So we're going to add solid components. So anything that's a solid in there, and we can just choose these from the model tree. Anything that's solid, obviously, it can't flow through. So we just add all of those in, and then it knows where the fluid can and cannot flow. Next, we want to pick the physics module for what we're doing, which will, of course, vary depending on what you're running for your simulation. In our case, we'll go ahead and bring in turbulence, heat, and some streamlines for our simulation today. You can also choose materials. So in our case, we're going to be looking at heat here a little bit as well. So we're going to pick what our thermal chip should be. And so if there are properties, that are specific and important to what you're doing based on material, you can have those set in here as well. Now that we have some of the background set up with the material and the physics, we're going to go ahead and start setting some of our conditions. So first off, we have to have a heat source, in our case, for the thermal chip. So we're going to make a heat source and choose the value for that to be 5 watts for that chip. And we can also put any outputs that we want for plotting. So in our case, we want to plot the temperature output here for this inverter. And so now that plot's set up as well for later when we run our simulation. Next, we can set some boundary conditions, so where the fluid is flowing in and flowing out, things like that. In our case, for the inflow, we're just going to have it be a pressure inlet, so there's nothing pulling the air, pushing the air, it's just an inlet. And on the opposite side, we are going to set that to a volumetric flow, and we're going to have that little fan there, so we can set the volumetric flow rate for that, and then we can generate our mesh. So once we have our mesh generated, we have essentially everything set up, so we can turn off the flow analysis body if you want to look at the mesh, and we can choose to show a surface here that we want to see how that mesh looks like, so we can see what they've done for the mesh grid. Again, as I discussed slightly earlier, it's got a more refined mesh around curves and a more general mesh there on flat surfaces. Once you have that set up, we're essentially ready to go here. So we can choose to run the simulation, and it's going to start giving us back some information right away on our temperature plot. So on here, we can see that we're spiking close to 400 degrees for the initial temperature and getting down to around 345 for our steady state temperature. If we turn on the streamlines, we can also see how that airflow is going through there. So we're getting some solid flow through the inlet and at the outlet where we have our fan, but we're getting a lot of turbulence in the center there. We're losing some of the air streamlines. And overall, this temperature isn't really what we want to get to. We want it to be lower. This is too hot. But before that, maybe we want to look at some of the information before we make any changes, really digest what we're seeing. So we could decrease the time per the streamlines so that we can see those differently. And we can also view the information in other ways. So you don't necessarily just have to graph things. As we talked a little bit in the PowerPoint, you have other ways of looking at this. So if we look at our surface, for example, here, we can display the temperature across that surface, see that all that heat is coming there from our thermal chip. We can also run section views. So if you would want to put a section through the center there, see how that heat is maybe rising up from the chip, where it's going, we can do that. And we can see from there that we're getting a little bit of a backdraft with the heat. It's flowing back instead of going out towards the fan, not something that we want. Next, we could also look at the ISO surface. So if we wanted to set an ISO surface in here, set it based on a variable, in our case, the temperature, we could say, I want to see, anywhere where the heat rises above a set temperature. And then we can see how that heat is flowing out from the chip from there. Now, once we've looked at this and, we do come to the conclusion, well, this is still hotter than we want it to be. It's getting too hot. We need to address that somehow. Well, we could start by maybe just changing our boundary condition. Okay, well, let's increase the speed of the fan. Let's see if that, helps to fix our issue. So then we can run the simulation again, and we could, again, turn on those streamlines, see how that looks differently this time. We can see that we have had some changes. First off, our steady state temperature is down from around 345 to around 325, 330, so some improvement there. And we've dropped from 400 down to around 365 for the max temperature. So we have lowered the temperature, maybe still not quite what we're looking to get to, but we are seeing some improvements just from that. And we can see in the streamlines that we're getting a little bit more of a steady flow from the inflow to the outflow. We are still getting a little bit of loss over there in the center, in the turbulence around the chip, but overall we're having better streamline from entrance out to the fan. Now, knowing this and seeing the improvements we've made, maybe we could again say, all right, well, we'll increase the speed of the fan again, but that's not necessarily the best way to have those improvements. Maybe there's a set limit to, whatever fan speed you can get, whatever it is. But the good thing about this tool is that, again, you are working inside of Creo. So while, yes, you could maybe change some of the boundary conditions again to try to make some improvements, you can also just go ahead and move forward by making changes to the actual model. You have that ability to toggle between doing this analysis, looking in here, learning information, and then closing out and being right back in base Creo, where you can go forward, make changes that will help, make improvements to your goals. Then you can jump right back into your simulation, see whether or not it's actually having the effect that you want, and make more changes, view what's happened, see if you're getting closer to your target, and go forward from there. So in our case here, we're just gonna pattern in a few extra cuts here to, let more air flow through on the one side. And once we do that, even though we've changed the model, it's still gonna be really easy to go back in and see how that's changed our analysis. So you don't have to start from scratch. We can actually open the project back up so it can save those projects for us. And all we need to do is update the fluid domain. So we've now had some new openings, so we're gonna need to add those. You could either choose to select those by hand and add those in, or again, we could just choose the two surfaces, say, okay, find all the holes there, remove whichever holes it is that, aren't actually holes, and it's still gonna remember all of the solids that are inside of there. We have all of our boundary conditions set up. So then all we would have to do is say, okay, well, now that we've got this all set up, we've got our plots ready, let's run it again. We've made some changes, let's see how it improves. And we've dropped another almost 5 degrees there for our maximum steady state and our steady state temperature. So seeing some improvements there, getting down to, the max temperature that we were looking to, and then able to maybe move on with our project. So, kind of at a high level there, just some real utility being able to not only view your answer or view the information that you're getting back in different ways, but also being able to save those projects and easily transition between doing that fluid analysis, going back into base Creo, making changes to your model, and coming back into the analysis and seeing what effect that's having. So I'll go ahead and close off here with a few more slides here. So just to touch on some of the value that this can really bring to a team is, number one, it's going to help you to be analysis driven earlier on in the cycle there. And that means that you don't necessarily have to rely on physical prototypes, so that you're not having late stage changes that might be difficult and time consuming, which means you can meet better deadlines and help to reduce your costs by not relying so heavily on prototypes. And all of that means that you can improve your product quality and your innovation, because earlier on in the development cycle, you can figure out new ways to approach issues. So that kind of covers what I have to show for CFD. Just to kind of leave something up here for you guys to look at. These are the different options around the flow analysis packaging. So there are different ones based on how in-depth you need to get. We start at the lower level, just looking at heat transfer simulation of flow and turbulence. Get into the plus if you're trying to look more towards things with particle flow and radiation, and then all the way down to the premium option, where you get further into multi-phase, multi-component, and dynamics. And one last thing to point out is that we did partner with a company called Cimerix to create this solution. So we took some of their tools functionality and embedded that into Creo. So if you're interested even further in seeing some of the kind of things around this, these images on the right with the gears and the planning halls and things are all from Cimerix. So you can actually go to the Cimerix website if you are interested and go to their gallery and see things that you can simulate. For example, here, just to show on their website, gear turning with oil flow and fluid inside of there. So if you are interested in taking a little deeper look and things like that, you can go to their website and check out some of their information as well. But I think that covers everything from my end.
We do have a question here, Cody.
Okay.
Looks like Tim was asking, these simulations often require complex judgment calls to be made while they're being set up. How are these judgment calls being made intelligently in the program?
So, I mean, I guess to answer that at a high level,
Yeah.
it is helping in setting up your boundary conditions. It's helping in generating that mesh for you and not having to worry about any of the backend information. Essentially, all you're having to do is give it the parameters that it's running with. So you do have to have at least some understanding there of what your parameters are going to be. But other than that, you at least don't have to be as in-depth in the background knowledge and understanding how it's actually getting to those results, if that makes sense.
Yeah, I believe so. If you have any further questions, we'll wait around for a moment. Looks like that's probably it. Again, we apologize for the audio issues when you first joined. We appreciate your patience. And thank you, Cody. That was great.
Yeah, absolutely.
And thank you, everyone, for joining us. As I mentioned, we'll have this replay up shortly on our website. You'll also receive a link to the replay about an hour from now. If you would like to learn more information, I've attached a white paper with further details, and more information can be found on our website, tristar.com, as well as more Creo events coming up. So thank you, everyone, for joining. Have a great rest of the day.
Yep, thanks again, everyone.
Thank you.